Next is the position of a root of a quadratic equation. That quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0 and the coefficients a, b, c belongs to the set of real numbers. The roots are, suppose, alpha and beta, and some of the roots are represented by the s and product of the roots are p. Also, the values of these roots can be given by minus b plus minus square root of b square minus 4ac by 2a, which can be written as minus b plus minus square root of capital D by 2a, where capital D is b square minus 4ac, is called the discriminant. And in terms of the sum and the products of the roots, we can write the quadratic equation as x square minus sx plus p equal to 0, and this s can be written as minus b by a, and product of the root p can be written as c by a. As we have already mentioned that the roots will be real if discriminant d is greater than or equal to 0. And in this, d greater than 0 states that roots are real roots and distinct roots, while d equal to 0 states that roots are real and repeated roots. That means same roots. And second is, the roots are complex roots if d is less than 0. Third is that quadratic equation has the shape of the parabola. This parabola may be upward opening or a downward opening if a is greater than 0 for upward opening and a is less than 0 for downward opening. So d greater than 0 refers that the parabola cuts the x-axis at two distinct points, and d equal to 0 refers that this is a repeated root or the parabola touch the x-axis at a point. This is x-axis. Similarly, if d is less than 0, then the parabola does not cut the x-axis, either it is totally above the x-axis or the below of the x-axis. Condition for the roots of opposite signs. That means if we see graphically that graph is cutting the x-axis at 2 points, say alpha and beta, and origin is in between, so alpha will be a negative root and beta will be a positive root. And if graph is downward opening, in that case also alpha is on the left hand side and beta is on the right hand side, so we can say alpha is negative root and beta is positive root. In this situation, product of the roots, which is equal to c by a, can be given as the alpha into beta, and one is the negative root and another is positive root, so this product will be less than 0. So we can say c by a is less than 0, or we can conclude that c and a are of opposite sign. If they are of opposite sign, then we can say roots are of opposite sign. One of the root is negative, another is positive. If roots are equal and of opposite sign, in this case also, product of the roots will be c by a and will be less than 0. That means c and a are of opposite sign. Additionally, sum of the roots, which is alpha plus beta, because these two roots are equal and in opposite sign, that means it will be 0. We can say minus b by a will be 0 or b equal to 0, as a cannot be 0 for a quadratic equation. So condition for the roots to be equal and of opposite sign, that b equal to 0 and c and a are of opposite sign. Next case is that roots are negative. In this situation, if we draw the graph for a greater than 0, the graph is upward opening. This graph cuts the x-axis at 2 points, say alpha and beta, and these 2 points lie on the left hand side of the origin. Or it may touch the x-axis at a point, and this point lie on the left hand side of the origin, and this point where it touch states that these are the equal roots. Similar graph will be drawn for the a less than 0 where graph is downward opening, cuts the x-axis at 2 points alpha and beta, and these 2 points lie on the left hand side of the origin, or graph may touch the x-axis at a point, say alpha beta, and this is also on the left hand side of the origin. For this situation, first point is that d is greater than or equal to 0. That means graph cuts the x-axis at 2 points or touch the x-axis at a point. Second is, because both roots are negative, then sum is less than 0. This implies that alpha plus beta is less than 0, or we can say because s is minus b by a, so we can write that is minus b by a is less than 0. Third is that product, which is equal to alpha and beta, it will be greater than 0 because both are negative, and negative on multiplication give positive. So this implies that product is c by a, so c by a is greater than 0. This c by a greater than 0 says that a and c are of same sign. That means if a is positive, then c should also positive, and if a is negative, then c should be also negative. From minus b by a is less than 0, this implies that b by a will be greater than 0. And in this situation also, a and b are of same sign. So from these two conditions, we can conclude that for roots to be negative, a, b, and c, which are the coefficient of the quadratic equation, are of same sign. Similarly, if both roots are positive, condition is d is greater than or equal to 0. That means graph cuts the x-axis at two distinct points or touch. Second is that sum of the roots, because roots are positive, so it will be greater than 0. This implies that minus b by a is greater than 0, or b by a is less than 0. So we conclude that a and b are of opposite sign. And third condition is product of the roots will also be 0, greater than 0. This implies that c by a is greater than 0, or a and c are of same sign. So finally we conclude that the coefficient of the quadratic equation ABC, a and c are of same sign and b is of opposite sign. Then the roots will be positive. Next is that number k lies between the roots. This number k refers the coordinate x equal to k lie between the roots which are x equal to alpha and beta, where alpha is less than beta. So graphically, this graph cuts the x-axis at 2 points. For a greater than 0, the roots are alpha beta, and point k is somewhere in between alpha beta, and the value of the graph or the function at point k is say fk, and from the graph we clearly see that this fk is less than 0. Similarly, if graph is downward opening, that means a is less than 0, it cuts the x-axis at 2 points alpha and beta. In between there is a point, say k, and value of the function at point k will be fk, and from graph we can say this fk is greater than 0. So condition for a number k to lie between roots is that discriminant is greater than 0. That means graph cuts the x-axis at two distinct points. And second is that product of a and fk will be less than 0, because if a is positive, fk will be negative, and if a is negative, fk will be positive. So this product will be negative. This gives the condition for number k lies between the roots. Similarly, if we take two numbers, say k1 and k2, where k1 is less than k2, and these lie between the roots alpha and beta, then condition will be again d is greater than 0. Second is that a into fk1 will be less than 0, and a into fk2 will also be less than 0. Next, to find the condition for k to be less than the roots, first we draw the graph. This is the x-axis and a graph is upward opening. For upward opening, a is greater than 0. It cuts the x-axis at 2 points. These are the roots alpha and beta. And there is a point k which is on the left side of the roots. The value of the function at point k is suppose fk is the point, and because it is above the x-axis, so it is greater than 0. Similarly, for other situations, we can also draw the graph that graph touch the x-axis for a greater than 0. There is a point k, and again fk is greater than 0. If graph is downward opening, it cuts the x-axis at roots alpha and beta. Point k is on left hand side, and the value of the function at k is fk, and here fk is less than 0. And if graph touch the x-axis at a point, say roots alpha and beta, and point k lie on the left hand side of the roots, then the value of the function at this point is fk, and it is less than 0. So we can find the condition that number one, this d is greater than or equal to 0. That means graph may be cutting the x-axis at two distinct points, or it may touch. Second is that k is on left hand side, and if we see the vertex of the graph, this is the vertex which is given by xv and yv. Vertex of parabola is given by the coordinate xv and yv, where xv is minus b by 2a and yv is minus d by 4a, where d is the discriminant. So we can say that k is less than xv, or we can say k is less than xv is minus b by 2a. And third condition is that a into fk. If we see the graph, a is greater than 0 and fk is greater than 0, so it is greater than 0. In second graph also it is greater than 0. On the downward opening graph, again, because a is less than 0 as well as fk is less than 0, so also here positive. So we can conclude that for a k to be less than the roots, a into fk will be greater than 0. So these are the condition for a coordinate x equal to k to be on the left hand side of the roots. Similarly, we can find a condition for k to be more than the roots, for which we draw a graph. So this is the graph with a greater than 0, cutting the x-axis at two distinct points alpha and beta, and k is on the right hand side, that is more than the roots. So value of the function at point k will be fk, and here fk is greater than 0. Similar situation for the graph touching the x-axis, it will be given here. This is the point k, this is fk, fk is greater than 0, a is greater than 0. This is the x-axis, and if graph is downward opening and cutting the x-axis at two distinct points, and there is a point k, this is alpha, beta. For downward opening, a is less than 0, and value of fk will be negative, so product will again positive. And if graph touch the x-axis for downward opening graph, again point k on right hand side will give the fk negative, and product of a and fk will be less than greater than 0, that means positive. So conditions will be that discriminant is greater than or equal to 0, that is graph cuts the x-axis at two distinct points, or it may touch. Second is that a into fk will be greater than 0, and third is that the vertex, which is xv, is on the left hand side of the k. So we can write that xv, which is equal to minus b by 2a, is less than the k. So these are the condition for k to be on the right hand side of the roots. Both roots lie between numbers k1 and k2. First we draw a graph. This is the graph cutting the x-axis at two distinct points, that is alpha and beta. There are the 2 points, say k1 and k2. For graph here, because upward opening a is greater than 0, and value of function at point k1 is fk1, and from graph we can say it is greater than 0, and similarly fk2 is also greater than 0. If graph touch the x-axis, then it is the equal roots alpha beta, and k2 and k1 are on the either side of the roots. K1 is less than K2, and value of the function at K1 is fk1, and here it is greater than 0, while fk2 also greater than 0. For downward opening graph, we can also draw this cut x-axis at alpha and beta, a less than 0. There are the 2 points, K1 on left hand side and K2 on right hand side. At K1, function value is fk1, and from graph we can see it is less than 0, that is negative. Similarly, fk2 is also negative. If graph touch the x-axis, it is alpha beta, K1 is on left hand side, K2 is on right hand side, and value of the function at K1, this is fk1, it will be negative, and at K2 it is also negative. So condition for both roots lie between K1 and K2 is number 1, D is greater than or equal to 0. That means graph cut the x-axis at two distinct points or touch the x-axis. Second is when A is greater than 0, then fk1 and fk2 both are greater than 0. That means positive. And if A is less than 0, then both fk1 and fk2 are less than 0. That is negative. So we can write that A into fk1, if both are positive, then product will be positive, and if both are negative, also product is positive. And A into fk2 is also greater than 0 or positive. Third one is that the vertex of the parabola lie between k1 and k2. So we write k1 is less than xv is less than k2, or we can write k1 is less than minus b by 2a is less than k2. Now to find the condition for exactly one root lie between k1 and k2. One root means that graph cuts x-axis once between point k1 and k2. If we draw a graph, it is point k1 and k2 on x-axis. Then suppose this is the graph, it will cut between k1 and k2 once. So at point k1, if we find the value of function, it is fk1 and it is greater than 0, while in case of k2, it is fk2 and it is less than 0. Also, if we take another situation, this is k1 and this is k2, and graph cuts the x-axis between k1 and k2 at a point, and at point k1, the value of the function fk1 here is less than 0, while at point k2, value of fk2 is also here greater than 0. So from this graph, we can conclude that for a root to lie between k1 and k2, condition is that function value at point k1 multiplied by function value at a point k2, because these are of opposite sign, will be a negative value. So this is the condition